So let's say we have one matrix that we'll call A, and that's going to be equal to a 2, 3, 1, and a 2. And we have another matrix that I'll call B, and that'll be equal to a 2, -1, 2, and a -3. And what I want to do is multiply A times B. So if I multiply A times B, what I'm going to end up doing is I'll take these two numbers right here, and I'll take these two numbers right here. And this is going to be the top left part of the answer for A times B. So if we do 2 times 2, and remember, when we're working with this matrix for multiplication, we're going to start the left and move right. And when we do this matrix over here, we're going to start the top and then go down. So we have this 2 times this 2 will be 4. And then we'll add on this number here times this number here. So that's 3 times -1 will be -3, and we'll add those up. So we have 4 plus a -3, and that's going to be a 1. So a 1 will be the answer for the top left part of A times B. So this new matrix right here will be a 1 right there. Now let's do the top right part. So we already have the top part of this. Now let's do the right part of this. So we're talking about these numbers right here. So if we do 2 times a -3, that'll be a -6. And we'll do a 3 times a 2. So we'll add them up, and that'll be a +6. So -6 plus 6 will be 0. So the top right part will be a 0 there. Now let's do this bottom part right here, the bottom, and we'll multiply it by the left part over here. So if we do 1 times 2, that'll be 2, and then we'll do 2 times a -1. Remember, we're adding these up. 2 times -1 will be a -2. Now 2 plus -2 will be 0, so the bottom left part will be a 0. Now let's do the bottom right. So we have a 1 here times a -3 over here. So 1 times -3 will be a -3. And we have a 2 times 2. We're going to add them up. 2 times 2 will be 4. So when we add those up, we get a 1. So the bottom right will be a 1. And this will be the answer for A times B. Now, when we multiply matrices together, A times B may not be B times A. But for this case, it will be the same. And that's because this matrix and this matrix are called inverses of each other. And we can prove that if I change out these numbers, if I do like this, and we have, let me fix that, that's a 2 here and a 3 here. And we'll erase this over here. So this was a 2, and this was a -1. Now this was a -3 was right here, and we got a 2 right here. So let's do, this time we'll do B times A. Now the first matrix that we have, we're going to circle that one left to right. So now this one we'll circle left to right like that, and we'll circle this one up and down like that. This is the row times the column. So again, for this matrix, it's going to be 2 times 2 will be 4, and then we'll have -3 times 1, so we'll have plus a -3, so we'll get a 1. So that matrix, the left and the top, will be a 1. Now let's do the top right. So this is the top part, and the right will come over here. So the right's going to be over there. So this we're going to have 3 times 2 will be 6. Then we'll have 2 times a negative 3. So we're going to add on 2 and 3 will be a negative 6. So the top right will be 6 plus negative 6 will be 0. So this right here will be a 0 for b times a. Now let's do the bottom part. So the bottom part, I'll circle this, and these are the numbers I'm going to be focused on. That negative 1 and that 2. And I'll have, let's see, 2 times a negative 1 will be negative 2. Then I'll have 1 times 2. That'll be a 2. So negative 2 plus 2 will be equal to 0. So this was the left bottom. So the left bottom part comes in here will be a 0. Now let's do the last one, the bottom right. So we want the bottom, so we'll have this row right here, and we'll have this column for the right. So we'll do negative 1 times 3 will be a negative 3. Then we're going to add on the 2 times 2, so we're going to add on 4. Negative 3 plus 4 will be 1. So the 1 will come in here. Now notice that this a times b is this matrix and b times a is this matrix. And again, that's because matrix A and matrix B are called inverses. So the book might give us a problem where they give us a matrix and they want to know what is the inverse of that matrix. And the way we figured this out is there's just a simple equation that we're going to use. So I'll put these numbers back. We had 2, 1, 2, and 3. And over here, I erase these red marks. And I had a 2, a negative 3, a negative 1, and a 2. And so let's imagine that they don't give us this. Let's imagine for a second that this is an unknown. We don't know what that is. And in the question it says, here's a matrix. Tell me what the other matrix is that it doesn't matter which one I multiply first or second by to give me the same answer. So what we would do if this was the question, this was the matrix we're given, and we want to try to find what this matrix is, the inverse of this, what we're going to do is, the equation is the determinant, and I'll put det, and we'll have 1 over that determinant, and then we're going to multiply it by the matrix that we're interested in. I'll call that matrix A, and it's the inverse of that. So basically, this will be the matrix B of this that we want. So to use this equation, first I have to know what this is. What's the determinant? How do I find a determinant from this? And this MA with the negative 1, how do I find what this is? And so I'm going to show you how to find this and this over here. So what I'm going to do is, for the determinant, I'm going to, there's an equation for that. Equation for determinant is going to be equal to, we have a matrix A, B, C, and D. And what we'll do is, we'll do A times D, subtract it by B times C. So for this matrix, what's the A is going to be a 2. So we'll have 2, and the D is right here, will be another 2. And we'll subtract that by B, which is going to be 3 for this, 3. And then the C is going to be a 1. So if we do 2 times 2, we'll get 4. And then we'll subtract 3 times 1 will be 3. So this will be 1. So 1 is going to be the determinant of this matrix right here. Remember, this right here is the question. Everything above this line is the question. Right here is just the formula. And then here's the work to get the determinant. So now that we got this right here, we got the determinant. Now I'm going to show you how to get this. So we take the inverse of this matrix, and to do that, I'll rewrite that matrix right here. We have 2, 1, 3, and a 2. And what I'm going to do is I'm going to take these two numbers and switch them. Now that may not seem obvious because these two numbers are the same number, but if they were different, we would still just flip them. This one would go over here, and this number over here would go over here. After I do that, I'm going to take this number right here, and I'll make it the opposite sign. So this is a positive 3, so I'm going to make it a negative 3. And this is a positive 1, so I'll make it a negative 1. So what that's going to look like would be something kind of like this. I have a matrix here. I'll have a 2 there and a 2 there because these two numbers switched. Even though they're the same, it doesn't look like it, like they switched. They really did. Now I'll have, this is going to be a negative 3, so I'll put in my negative 3. I change the sign. This will be a negative 1, so I'll put negative 1. So now this right here is going to be this right here. So now that I have the determinant, which is 1, that I figured out from right here, this equation, and here's my matrix, I can now find what the inverse would be for this. So basically, I'm just going to combine, I'll separate this out. I'm going to combine this information and this information into this equation, and hopefully we get something looks like this. So we have 1 over the determinant. The determinant is going to be 1, so I'll put 1 over 1. I just replace, this is the det is 1, and we have 1 over dt is 1, so I have 1 over 1. Now the matrix of this MA right here with negative 1, that's going to be this right here. So that's going to be a 2, a negative 3, a negative 1, and a 2. And then I'll have this 1 over 1 times this. So 1 over 1 is just 1. Now all I have to do is distribute this 1 to each part of what's in here. So this 1 over 1 is just 1. We'll go here, multiply that by 1, multiply that by 1, multiply this by 1, and multiply this by 1. Now obviously 1 over 1 is 1, and it's not going to change this overall. So what our answer would be is the inverse of that, of this right here, would be 1 times 2 will be 2. 1 times negative 3 will be negative 3. 1 times negative 1 will be negative 1. 1 times 2 will be 2. And this right here would be our answer. Right here. This is the answer. And it's good because this right here matches right here. And we already know, because we already worked this out, that A times B and B times A give us the same answer. So if we did not know this, if this was our unknown, we could still figure out what this would be based on using this equation right here. And that's because we know the determinant is right here, this equation, and we know how to flip this matrix right here by doing this process right here. So this was how you would work out this question.